Alright, I wanted to answer 30 and 39 because they were asked as homework questions. So I'm going to go over those right now. 30 we've been doing a lot of throughout pre-calc, but now we're adding the odd and even idea, but it's essentially your transformation. So in the first one, you have a -2, which means you got a vertical flip for the negative and then a vertical stretch of 2. So I would start with these points and then also use your x-intercepts. And what we're going to do is we can also use this one and this one. So those points and all those y-coordinates we're gonna flip over and then multiply by 2. So for like the -1 or for the 1, we'll flip it over, we'll get -1 and go down to -2. Same with this one. And then x-intercepts always stay the same. And over here we have a -1, we multiply by a -2, we get +2. And your graph will go something like this. And there's your graph. So that's A. B, you have a horizontal flip, and then you have a vertical shift of 1, and the order is important. You need to horizontally flip it first. So, horizontal flip, these will be in the same places. And then this guy will actually go over here, and this one will go here. And this is at 5, so this will be -5 here. And then it'll even out. Now we got to shift it 1 up. So it'll be here, here. So I'm just shifting every point up 1. This will come down. This will keep coming down like this. And then this will just go across. So it's been horizontally flipped and then shifted up 1. The last one is reciprocal. So this one's a bit tricky. We talked about this a little bit. We haven't done chapter 5, but when we look at a little bit of chapter 5, this will make more sense. So each of the x-intercepts at, what is it, -2, 0, and 3, 0, you'll notice your y-coordinate is 0. Well, if we do 1 over 0, you're going to get undefined, which means you will have an asymptote. At those points. So what that means is we'll have an asymptote at 3 and an asymptote at -2. So at -2 we have an asymptote, and at 3 we have an asymptote. The next part of this is finding out where it's positive and negative. Well, it will be so since these values are positive, and then these values are negative, you look for clues. A 1 over a negative will give you a negative, which means this graph has to run along this asymptote, and it'll all be in the negative area. This positive will have to be up here, because it's got to run along the asymptotes, and it's above the x-axis, and then here's the other negative. When we look at chapter 5, this might make a little bit more sense, but for now it's good to have a preview of it. Alright, so on 39 it's kind of the same. On 39 you're going to be ending up expanding and simplifying, so this is just algebra. And you could do this u substitution. I'd probably make u equal the cosine of theta. So then you get 7 minus u squared. Oops, 7 minus u squared, which is totally different. Just 7 minus u times, which will end up being 49 minus, what, 14u? U plus u squared, and oh, I should have made it 5 cosine theta. There we go. Alright, so we get 49 minus 14 times 5 cosine theta. There's your u substitution, plus 5 cosine theta squared. And this final answer, so you see the u substitution right here, would be 25 cosine squared theta minus 70 cosine theta plus 49. Sneaking it in. Okay. The next one, I'm going to do on a separate page. So this one is sine of theta plus cosine of theta squared. I'm actually not going to do u substitution on this. I'm just going to multiply it out. So you have 2 of these. Which will be sine squared of theta plus 2 sine theta cosine of theta plus cosine squared of theta. And what do we have here? This is equal to 1. So we have 1 plus 2 sine of theta cosine of theta. And this looks familiar. This is 1 plus sine of 2 theta, your double angle formula. There it is. Alright, hope that helps with 39. So algebra with a little bit of trig.